Okay, it's 1 o'clock, so let's go ahead and get started today. All right, good afternoon, everybody. How's everyone doing this week? We'll be about a third of the way through the semester after this week. So I know some other faculty are having midterms, so hopefully you guys are not dealing with too much. So the plan for today is we're going to start a new set of lecture notes called annual cash flow analysis. So basically, this is, you'll see that it's very similar to present worth analysis. At least all the same ideas apply, but instead of converting to a P, we're going to convert everything to an A. So hopefully this is, compared to present worth, hopefully this is not too big of a jump. Right? And then the other, thing that we have to talk about today is the midterm. That's coming up for next week. So before I talk about the midterm, I think we have a homework due tonight, I think, right? So are there any questions on the homework or what we covered last week that I can answer before we talk about the midterm? Okay, so let's talk the midterm. So the midterm is next Thursday. So there's still a typo in the syllabus, which I keep forgetting to correct. But I'm going to say, basically right here that the midterm is going to be next Thursday. Okay. And the date for that is October 1st, I believe. Yes. Right, so don't go off the date in the syllabus, because the date in the syllabus actually doesn't exist. So the date in the syllabus says it's Thursday, September 29th, but obviously that doesn't exist. That was actually the date from last year. I think I just forgot to update it. And so the midterm is going to be Thursday, October 1st. Okay. And so let's talk format. So everyone's kind of doing I know every faculty is kind of doing something a little bit different. I know some are using Factorio, some are not, but for me, I don't really feel like using Factorio because I think it's creepy as hell for me to to install some software on your guys' computer and for me to kind of basically spy on you guys when you're taking the test. It's not for an in-person exam, that's kind of what naturally happens. But I mean, we're not in the classroom, right? You guys are in your home, so I want to respect the privacy and everything of your homes and especially your own computers. So the way I understand Factorio is that it also keeps track of what tab you have open on your computer. That's a little bit too much for me. I don't want to know that much about you guys. And so I'm not going to use any software like that. So basically what I'm going to do is I'm just going to upload the exam onto Canvas, and then you guys are just going to complete it and then send it and upload your solutions back. Let's talk time frame. So I think across the board we've talked among our faculty that said we should give more time for the exam because you guys there's some more technical things that you guys have to do. You guys have to scan, you have to upload the questions and stuff like that. So I know some faculty are just giving a few extra 30 extra minutes, 20 extra minutes. But I know a lot of you guys your schedules are pretty busy, so you might have a class after this. So I don't want to just give an extra 30 minutes because if that runs over into your next class, I don't want you to miss anything from that as well. So what I'm going to do is I'm going to give you guys 24 hours. Okay. And so what that means is that basically next Thursday on October 1st, I'll start the exam at our normal lecture time. So I'll enable the exam at 1 p.m. next Thursday, and then you'll have until 1 p.m. On Friday to answer the questions and basically upload your solutions back. So to me, an exam, even the in-person exams, time should never be a big issue on the exam, because I remember growing up and I remember taking SAT classes and everything. And I felt like more of those SAT classes more just teaching you how to just do a test. They're like, oh, if you don't get this one, skip it and don't guess on that one because they're going to subtract. Like test taking should not be a game. I don't think it's it's not a game for to kind of game the system. I always felt like it's a chance for you to basically show off what you've learned and show that you have some mastery. And the exam itself is less important than the studying for the exam, because that's ultimately what I want you guys to do, is to study, learn the material, and to practice it, right? And so time, I never want time to be an issue on the exam, and especially now with this pandemic, I think that's even more reason to be more accommodating. So you guys are gonna have 24 hours, so definitely use all the time that you need. But in terms of the exam length, I'm going to write it basically as if it was like an in-class exam. So I'm going to write it as if it was like a 75-minute exam. So I'm going to take the exam. Usually my policy is that if I try to finish the exam in less than 20 minutes, so if I can finish the exam in less than 20 minutes, then it should take you guys roughly about 75 minutes. So at least block off a 75-minute chunk for you to do the exam, but definitely use more time if you need to. Use up the whole 24 hours because that's going to be there for you. Okay. In terms of content, it's going to cover basically that first big, huge lecture notes that we did on like interest rates, converting between the different cash flows. It's going to cover present worth analysis, and it's going to cover up to what we do this week on annual cash flow. And so this semester has been a little bit weird because like we've kind of had a lot of kind of workshops, and like we had James come in for a lecture too. So a lot of time has passed, but the amount of content that we've done is probably comparable to what some of your other classes are doing for their midterms as well. And so that's the content. Let's talk format. So I know there's some of you who've taken me for a class before. And so for those of you who have, the format's going to look very familiar. But for those of you who haven't, this is what I typically like to do. So the format of the exam will look very similar to your homeworks. So there will be an initial problem. Okay, so we'll call problem 1. And this will be a short answer problem. Right? So there will probably be 4 parts to this problem, and each one you'll have to answer with 3 or 4 sentences or write out an equation or something like that. And the idea behind these short answer problems is that these kind of test your conceptual understanding of the material. Okay, and so this will be worth 40% of the points. Okay. So I think conceptual, understanding is something that's really important. So, these short answer questions, I do weigh them pretty heavily. Okay. So it's very similar to the homeworks actually. So if you're answering the homework problems and you're doing the first problem and you can write out solutions to that, you should be in good shape for this. Okay. And problems 2 through 4, these are going to be like problem solving questions. So these involve maybe doing a present worth analysis, or maybe doing annual cash flow analysis, or finding equivalent cash flow. So basically anything that's after problem 1 on the homework, that's what problems 2 through 4 will look like. Okay. And then by process of elimination, this will be worth 60% of the points. Okay. Okay. And so, so that's kind of all the statistics for the exam, or just kind of the information you need to know, right? All right. So, question in the chat: so will we get the solutions to the previous homeworks prior to the test so we can study for the problems that we missed? Yes. Yeah. So I'm going to upload all the solutions. So basically, what I do is I upload the solutions as soon as I finish grading. And so for homework 2, I'm going to try to grade that by the end of this week. Yeah, homework 2 is pretty tough. And so before the end of this week, you should have the homework 2 solutions. I'm going to assign 1 more homework today, just so you guys get some practice with annual cash flow, and that'll be due next Tuesday. And then I'll upload, and then that one will be a little bit special because I probably won't have time to grade those before the exam, and so I'll upload solutions to homework 3 basically as soon as everyone turns that in. Yeah, it was long and hard. So the homeworks if you kind of looked at your grades for homework 1, what I did was I graded half for completion, and I also graded 1 of the problems for correctness. So so there's always going to be 1 problem on the homeworks that I'll grade for correctness, and the rest I'll mostly grade for completeness, and mostly I'm just checking to see that you did it. Okay. The exam won't be like that. The exam, everything will be graded for correctness, just because that's just kind of how exams have to be. Okay. And so one thing I'm doing for the other classes, so just because of the virtual instruction, I'm going a little bit slower on a lot of my lectures than I would like. And so we're not going to have time for an in-class review session. But what I said instead was I could pre-record a review session kind of in my own time, because I don't want to have an interactive Zoom call for a review session if not everyone can make it. And so what I can do is I can pre-record one, and I can post that up onto Canvas so that you guys can have that to study as well. Yeah. Okay. What else? Study guide. So I'm going to also upload a study guide for the exam too, so that basically you guys will be able to have that to help you study. just so you can kind of know, just so you can kind of use that to kind of guide your studying and see what you need to do. And so the study guide, all it's going to be is just going to be a list of all the learning objectives that we covered. But I think just having it all in one place and kind of cross things off on that list, I think is helpful for studying as well. Any questions on the exam or anything?
Yeah, Professor.
Hmm?
How accurate will our answers have to be? Because I noticed on the homework I was always off by like maybe $1 or a couple cents for some reason.
Yeah. So it doesn't, of course, it doesn't have to be exact. It's like depending on how you apply the formulas and how you apply the table values, and like every calculator internally is a little bit different. So if you're I'll say, so if your process was correct, so you set up everything correctly and you said like this has to be converted to a P or use the correct formulas, that's where basically all the points are going to be. If your final answer is just a little bit off, but everything else that you have in the problem is correct, I'm going to give you basically all the points. I really like to grade your homeworks and all your exams on the process, because I feel like that's what we're learning here in the class is how do you actually go about doing these problems. And so, if you're just a little bit off, that doesn't matter. That doesn't really matter to me. Actually, someone asked me on the homework for like a problem where the answer was like in the millions. He was like 10,000 off. So 10,000 sounds like a lot of money, but 10,000 relative to like 9 million is not that much. So he would still get full credit for that one as well.
Yeah, thank you.
Mm-hmm. All right. Any other questions? Okay. Okay, and so I'll make a comment on the homework too, that I think, because I did get a lot of questions about it over the weekend, that I think, the most difficult thing or the most difficult step up from this homework compared to some of the other ones is that all of these are pretty complex word problems. So you really have to kind of read the problem. And I think the difficult thing is that you have to really pick out the information from the word problem in order to use it in an economic analysis. So kind of the advice that I've been giving to everyone is that, read the problem, take every time you see a dollar sign or every time you see a number in the problem, write that number down and then classify that cash flow. So is this an initial cost? Is this a maintenance? Is this a future sum? Classify what that is, and then just keep doing that as you go about the problem. And then read the problem again and see what do I have to find for this. And then if you kind of identify all those things, then I think it makes the problems a bit easier. And then the other thing that really helped is to draw the cash flow diagram. So I know the cash flow diagram is kind of it's a hassle to draw. I dislike drawing it too, just because it takes so much space and it takes a while to draw the little dots. But it really does help, because the cash flow diagram basically should visualize everything that's going on in the problem, and that can only help you with the solution, especially for the ones that have a lot going on. Like I think problem three tripped a lot of people up just because there were a lot going on. Especially 3B, I think was really difficult. So draw the cash flow diagram, fill in everything that you can. I try to write the word problem so that there's no ambiguity on what you need to fill into like a cash flow diagram, and then from there, that should give you a huge leg up on how to do those problems. Okay. So there's that, and so now let's start the next lecture notes. So the next lecture notes are going to be on annual cash flow analysis. I have just random brain farts where I forget how to spell stuff. Okay, and so last week what we covered was, or I guess for the last 2 weeks, we went over present worth analysis, where present worth analysis, we learned that it was a way to basically perform comparisons between different economic alternatives. So the situation that kind of presents itself a lot is that you're an engineering manager, and you have to buy a certain machine or something, and you're comparing 3 or 4 different vendors. And so what we did was we computed the present worth of each option, and we saw which one had the highest value, and that was the one that was most economically efficient for the company. Okay? And so annual cash flow is kind of the sister analysis to that, where basically you're doing the exact same thing. So you're basically performing economic comparisons, but instead of converting everything into a present sum, what you're doing instead is converting everything to a uniform series. Okay? And so to sum that up, basically annual cash flow analysis is a way to do economic analysis between comparisons or between options, I should say. Okay. And the way we're going to do that is we're going to compute an equivalent uniform series to represent the entire project. Okay. And so in present worth, remember we computed a present sum, annual cash flow, we're just computing a uniform series. So it's the exact same concept. It's just a different thing. Okay. And so why do we have this? So if we already have present worth analysis, why do we need a different method that does basically the same thing, just in a different form? Well, it's all about how you interpret the results. And so with present worth analysis, what we talked about was that the way that you interpret those results is that if you perform present worth and you get a certain number, then it would be the either investing or paying out for a machine would be exactly the same as if someone handed you a check with that much money to you today, and you can cash out that check, or you have to write a check with that much today. And so with annual cash flow, the way that you interpret it is that this is this is like a yearly sum of money that you have to pay every year. Okay. And so just from the interpretation, sometimes annual cash flow makes a little bit more sense than present worth, just from the interpretation. So I think the number one case for this would be a loan. Okay. And so if you're taking a loan out either from a bank or from another business, you want to find out how much that you have to pay for that loan every year. And then doing an annual cash flow analysis will be a nice way to say, this is how much money I have to do every year, and it kind of helps with budgeting a little bit more too because of that. Okay. And so we'll go much more deeper into loans probably on Thursday. But for today, we're going to go over kind of the just the basics of annual cash flow and just do a bunch of examples with it. Okay. All right. Any questions on this before we start going over some more definitions? Okay. Okay, so let's go over some new definitions. And so since we're converting everything to a uniform series, we can classify it as different parts of a project according to whether they're a cost or a benefit, or if it's their net worth. Okay, so let's go first over equivalent uniform annual cost. Okay. And so, of course, this is something that's really long to say, so we have an acronym for it. Okay, so it's EUAC. Okay. And so the equivalent uniform annual cost, this is basically just all the costs that are associated with your project converted to a uniform series. Okay. And so usually for most projects, you would have things like an initial cost, a maintenance cost, maybe like an overhaul cost. So you would take all those costs and basically just convert it to a single uniform series, and that's going to be your EUAC. Okay. And so to compute EUACs, you don't consider any benefits, you don't consider any revenue or any salvage value that you might do. It's strictly just the costs of your project, and you convert that to a uniform series. Okay. So that's equivalent uniform annual cost. So that's our first definition. Okay. And if we're going to categorize all the costs, then we have a similar definition for benefits. Okay. So we have equivalent uniform annual benefit. Okay. And this has the acronym EUAB. Okay. And just like the definition for EUAC, this is simply just going to be all the benefits of your project converted into a uniform series. Okay. All right, so that's EUAB. And then finally, the last definition that we'll go over is equivalent uniform annual worth. Okay. And simply, this is you can kind of think of this in a couple ways, but probably the one that you'll use for the problems is that this is just all the costs and all the benefits of the project converted to a uniform series. Okay. Okay. Another way to compute this is you just take the difference between EUAB and EUAC. Okay. So EUAW is equal to EUAB minus EUAC. Okay. All right. And so most of the times when we're doing annual cash flow analysis, you're going to compute the EUAW for that particular project. Okay. And so most of the times you're not going to worry about EUAB, EUAC, but they're just important definitions to know in case you kind of run across those terms in practice. Okay, any questions on these before we do an example?
Yeah, Professor, I didn't catch, what is the exact benefit to converting to uniform series versus looking at it as like a initial cost at the beginning of the year? Does it let you like make predictions about future values?
Yeah. So it's all just about the interpretation. So actually, if you'll see this in the homework too, where if you can do a present worth analysis, you perform an annual cash flow, you should come to the same conclusion, or one option should always be better than the other one. But it's all just about the interpretation. So for the present worth analysis, the way that you interpret those results is, this is the present day value of this project. So this is the amount that we would have to pay today, or this is the amount of money that we'd earn from this investment today. But for an annual cash flow, some people might find that to be a bit easier to work with, because this shows you something that you would have to pay out every year. So for like budgeting purposes, where you're trying to plan a budget for an over a long time, and you want to see what the equivalent thing that you have to pay out every year, this might be something that's more useful for that. Or if you're thinking about like a loan or something, then annual cash flow is kind of a more natural way to think about it than just like a present worth value of it. Does that make a bit more sense?
Yeah, that helps. Thank you.
Okay. Okay. So let's actually redo an example from last time, but instead of doing a present worth analysis, let's do it with annual cash flow. Okay. And so let's say that you work for an engineering firm, and you're deciding between two machines. Okay. Okay. And so let's say that machine A Machine A has an initial cost of $10,000. Okay. And it results in a $3,000 savings annually. So I should say saves the company $3,000. Okay. And so you know, that's the cash flows for A. So machine B. Okay. And so machine B has an initial cost of $13,500. Okay. Machine B also will save the company $3,000 every year. Okay. But in addition to that, it's going to save, the savings are going to increase every year. So there's going to be a gradient of $1,500. Okay. And so if we assume an interest rate of 7%, okay. And how many years are we doing this? And so we're going to do this for 5 years. Okay. So assuming those parameters, let's use annual cash flow analysis to determine which machine is the better buy for this. Okay. And so this is a you know, an example we did with present worth. So in present worth analysis, we took each of these cash flows. So we would take this 10,000, we would take this 3,000 right here, you know, for machine A, and we convert everything into a present sum. And so from that, we got one number. Okay. And then we do the same for B. So for B, we had an initial cost of 13,500, a maintenance cost of 3,000, and a gradient of 1,500. Okay. And we take all those things and convert them to a P, and then we would compare, you know, which one was better. And so for annual cash flow, instead of converting to a P, what we're going to do is convert these into an A, and that's what's going to give us our solution. Okay. All right. Any questions on the problem setup? Okay. So let's do the equivalent uniform annual worth for option A. Okay. And so the way that we usually write this, we say that EUAW. Okay. And we'll give it the subscript A for option A. And what we're going to do is we're going to take all the cash flows in the problem and convert it to a uniform series. And so let's start with the initial cost. So remember, our initial cost was $10,000. So we represent that with the minus 10,000. Okay. And then we need to convert this to a uniform series. So we're going to multiply this by an A over P factor, 7%, and 5 years. Okay. Okay. And then to that, we're going to add the annual savings. So, you know, this saved the company $3,000 every year. And so we just have to add 3,000. Okay? And since this 3,000 is already in the form of a uniform series, we don't have to perform any conversions here. Right? Right? And then from this, we look for this guy in the table right here. Right? Or you can use the formula if you're more inclined. Then we get an equivalent uniform annual worth of $561. Okay? And so that's the you know, how much money that this machine is going to be worth every year. So, you know, if you're budgeting for this machine, you can basically add a surplus of $561 every year, you know, from this machine in total. Okay. All right. So now let's find the equivalent uniform annual worth for option B. And so our option B, we're going to do the same thing. So we're going to take our initial cost of 13,500. we're going to convert this initial cost to a uniform series. So that's multiplying by an A over P factor, 7% and 5. Okay. Next, we're going to add our annual savings. So remember, our annual savings start at $3,000. Okay. And then we're going to add our savings, or our gradient savings. Okay. And so our gradient was, let's see, $1,500. And then we're going to convert this A to a G. So we have A over G, 7% and 5. Okay. And then we plug in the numbers, and then what we get is $640. Right. Where again, you know, everything I have in parentheses here, we look up in the tables. Okay. Or you can use the formulas if you want. Right. And so from this analysis, we can see that option B has a higher equivalent uniform annual worth. So the company should buy option B. Okay.
What does this number really mean, though?
And so this would be kind of the same. So, remember before with present worth, you know, we computed a number, and that's basically the amount of money that you would make, you know, today. This number, the way you can think of it is this is the number net overall that the company would earn every year, you know, by investing in this machine. So by taking the initial cost into account and all of the other benefits, you know, purchasing these machines would be like getting a check for like $640 every single year for the life of this machine for 5 years. Yeah.
So they're saving this money.
Yes, they're saving this money. Mm-hmm. Okay. Any questions on this example? Okay. So mechanically, you know, these problems are very similar to present worth. You know, you're going to run through a lot of the same calculation, or you're going to run through the same process, but instead of converting to a present sum, you're going to convert to a uniform series. Okay. Okay. So let's throw some complications at this. And so if you remember when we did present worth, we had to make some adjustments when our product lives were different, right? Okay. And so, you know, the main thing that we had to do was we basically had to find the least common multiple, most commonly. And then what we did was we bought a replacement for the machine every time a machine was used up. Okay. So one of the really nice things about annual cash flow is that, you know, you don't have to go through the whole song and dance of actually of buying a replacement and having that factor into your cash flow. And so for annual cash flow, it actually becomes a little bit simpler to handle cases where the project lives are not the same. Okay. So let me show you that with an example. Okay. And so actually, this is an example that we also did before, but now we're going to do it with annual cash flow analysis. Okay. All right. So in this example, we have 2 pumps. And they're being considered for purchase. Okay. And so I'll write up the stats for the 2 pumps right here. Okay. So we have pump A. Okay. And we also have pump B. Okay. And so the first thing we'll consider is their initial cost. Okay. Next thing is they have a salvage value. Right. And last thing that we'll list is how long the pumps will last. So pump A has an initial cost of $7,000. Pump B has an initial cost of $5,000. Right? The salvage value will be $1,200 for pump A. Okay. The salvage value for pump B is $1,000. Okay. Okay. And then the useful life for pump A will be 12 years, and the useful life for pump B will be 6. Okay. And so let's also write out the interest rate. And we have an interest rate here of 7%. Okay. And so when we did this problem for present worth analysis, we basically set our entire project life to be 12 years. And then for pump B, what we did after the first one broke was we bought a new one at year 6 for the exact same cost. Okay. And so let's redo this problem, but with a annual cash flow analysis. Okay. All right. Any questions on this before I turn the page? Okay. Okay. So let's compute the EUAW for each of the pumps. Okay. And so let's do EUAW for pump A. Okay. And so for pump A, we had an initial cost of $7,000. We have minus 7,000. Right. And then to convert this into a uniform series, we multiply by an A over P factor, 7%, and 12 years. Okay. And then we have to add its salvage value. And so remember, the salvage value happens at the end of life. And so that's going to be an A over F factor, 7%, and 12 years. Okay. And then what we get is an equivalent uniform annual worth of $814. Okay. All right. And so that's the EUAW for pump A. And so let's do the same thing for pump B. Okay. Okay. And so for pump B, I'm going to perform the calculations as if it were just had a life of 6 years. So I'm not going to buy a replacement. I'm just going to use basically the stats that are given to me straight from the problem. Okay. And so first we have to factor in our initial cost. Right. So initial cost is $5,000. Okay. And this is going to be A over P, 7%. And then since pump B it will only be able to last 6 years, then we use a life of 6 years right there. Okay. Okay. And so the next thing that we have to compute is the salvage value. So that's going to be a plus 1,000, A over F, 7%, and then 6 years. Okay. Okay. And then we add those up, and then what we get is minus 909. Okay. Okay. And so from this analysis, we can basically conclude that pump A is the better one. Okay. Because it's less negative, right? But then, you know, you look at this analysis, and especially compared to how we do it with present worth, you're probably like, oh wait, you know, OxyClean. No, but you know, you said, you know, we can't do this because pump B only lasts 6 years, and so it looks like we're comparing apples to oranges right here. So we're comparing one thing with a horizon of 12 years and another thing with a horizon of 6. And so this usually is not a you know, a fair comparison. But, you know, what I'll show you right now is that actually, you know, when you're doing things in terms of annual cash flow, you know, it actually doesn't matter. So let's actually do the problem and let's actually recompute B, but let's do it over a horizon of 12 years. Okay. And so what that means basically is that in year 6, when the first pump runs out, we're going to purchase a new one at the same price. Okay. And so first thing let's do, let's draw out the cash flow diagram. Right. And so at year 0, we have our initial cost. So this can be a minus $5,000. Okay. And year 6, we salvage the first one for $1,000. And then we also buy a new one for another $5,000. And then at year 12, you know, once we're all done with it, we can salvage it for another $1,000. Okay. And so let's take this cash flow diagram and let's convert everything to a uniform series. Okay. Okay. Any questions on this? Okay. And so before we actually go to the next page, I will make a note of the cash flows that are happening in this year right here. Okay. And so, you know, in order to convert this into a uniform series, what we'll see is we'll need to do 2 conversions. So this will be like very similar to what you did for problem 3 of the homework, because this is an irregular cash flow. It doesn't match the same pattern as before. Okay? And I'll show you what I mean by that. Okay, so let's start our conversions. Okay, so first we have our initial cost. So first we have our initial cost of $5,000. And so in order to convert this to a uniform series, we just simply multiply by an A over P. Okay, and then our interest rate is 7%. And then this is going to be over 12 years. Right? Okay. And so now let's do that, that uniform series right there. Okay. And so that uniform series, basically we have a minus 5,000 and a plus 1,000. So this can be the same thing as a minus 4,000. Okay. And so I think the first thing that people would try is that, you know, we have these this future sum right here. So it's a sum that happens in year 12. And so in order to compute, or it happens in year 6, sorry. And so in order to compute this to a uniform series, all we got to do is multiply by A over F, 7%, and 6 years. Okay. Right? And so you would think that that's all you have to do. But actually, in this particular case, this is wrong. Because what this quantity right here actually computes, this takes that $4,000 uniforms, this $4,000 future sum, and it spreads it out over 6 years. Okay.
Sorry, I may have missed it. Is it $4,000?
Yeah, it's the sum of a minus 5,000 and 1,000. So added together, it's a minus.
Okay.
Okay. And so what this is basically doing is that it converts this minus 4,000 in the future into something like this. Okay. And so this is actually not what we want, because we don't want a uniform series that's only spread across the first 6 years. We want a uniform series that's spread across all 12 years. Okay. And so this is actually not how we're supposed to do this one. Okay. And so the way that we can do this is we do a minus 4,000. Okay. And then the first thing that we have to do are, you know, you can do this actually 1 or 2 ways, but let's bring this 4,000 and let's put it onto the present day first. Okay. And so what that'll do is that'll convert the equivalent worth of that $4,000 into present day money. Okay. But we're not doing present worth analysis. We're doing annual cash flow. And so now that we have the sum of money in the present day, right? So this converts $4,000 to present day. Okay. Okay. And so the reason that we want to do this is because we want to take this and then we want to spread it out over all 4 years. And so the way that we have to apply one more conversion factor. Okay. And so if we multiply this quantity by A over P, 7% and 12, this will take that sum and spread it out over 4 years. Or 12 years, sorry. Okay. Right. And so that's why I kind of labeled this as an irregular cash flow from before, because if you have a future sum that's in year 6, that's something that's not our full length. If we directly try to convert that to a uniform series, it would only be a uniform series up to that point. But we want this to be a uniform series for the entire thing. So first thing we got to do is we got to take this future sum, bring it back to the present day, and then once it's in the present day, apply another conversion factor to spread it out over all 12 years. Okay. All right, question. So question is, could we have multiplied the A over the thing I crossed out by A over P 7% and 6? And so that's one thing that you couldn't do either, because that would spread it out for the last 6 years instead. And so that would take that one sum in year 6 and then spread it out from year 6 to year 12. And so we want to spread this out, evenly throughout from years 1 through 12. And so that's why we kind of need to do 2. And so if you just kind of do it in one step, you're either going to get kind of the first half or the second half. But we want to be able to spread it out over the entire.
I meant by like multiplying both of them. Could you have done that by any chance? Like AF 7% 6 times AP 7% 6.
No, because the second one has to be, one of them has to be 12 years, because remember we want to spread this out over 12 years. So if you do 2 things with 6, then you're just kind of converting things within like 6 years. So you need to have one of them. You need to have this something with an A on top, and then have that go over 12 years, just to make sure that it's spread over the 12 years.
Okay, that was just a question, but thank you.
Yeah. Mm-hmm. Okay. And so that was definitely kind of the most complicated part. Anytime you have an irregular cash flow like that, you really kind of have to, think through it, and usually perform multiple conversions in order to make it work. Okay. And then the last thing that we have is a salvage value in year 12, and so we have a plus 1,000. Okay. And since this is already in the final year of the of our horizon, we can just multiply this by A over F. 7%, and then 12. Okay. So this guy we only have to do one value because it's already, it's already at the end of our thing. So if we spread this out over the 12 years prior, that's the exact uniform series that we want for this problem. Okay. Okay. And so we have all of these, and we can basically sum them all up. And then we sum them all up, and then what we get is minus $909. Okay. And so if you compare this to what we did before, where we didn't, go through this whole thing of, buying replacement, this is the same as we got before. And so what this example basically illustrates is that, when you're doing, an annual cash flow analysis for a project with different lives, you don't have to go through this whole song and dance of like buying replacement, doing these like really weird cash flow conversions. You just take the whole thing and then you just convert everything that has given to you into a uniform series, and that gives you basically the exact same answer as as if you did buy the replacement. So this is one of the really nice things about annual cash flow, because it's when you have projects of different lives, which does happen quite often in practice, you can just use annual cash flow and you'll arrive at your solution a lot faster with a lot less steps than if you did present worth analysis. Okay. Okay. Any questions on this? Okay. And so, before we move on, I just want to kind of remind you of kind of the big assumption that we made in the previous problem was that, if we are doing annual cash flow analysis for things with different project lives, the implicit assumption is that, you buy a replacement at the same cost. Okay? And so that whole thing that we just did is, it depends on the assumption that replacements can always be bought at the same price. Okay. And so again, remember that's always kind of a big assumption because usually companies won't sell the same product for 5-10 years, and if they do, they're probably either going to jack up the price or actually the price might be less if they're trying to get rid of inventory. So it's a big assumption, but it's it makes our lives a lot easier. Okay. All right. And so sometimes what you'll see for these kinds of problems too is that they'll give you all the initial costs and the useful life, salvage value, and all that stuff. But one thing that they might tell you in the problem is that the company plans to use these machines indefinitely. And so oftentimes these could be things like essential kinds of machinery. So like a hospital might purchase like an air filtration system or like a ventilation system, and that's something that they plan to use forever. So in those situations, you can still apply annual cash flow analysis, exactly the same way as we did before. Even if you don't find like a least common multiple between the machines too. Okay. So basically don't be alarmed if you come across a problem where it says it can be used indefinitely, because annual cash flow is basically designed to handle these kinds of problems. Okay. And so that's basically the basics of annual cash flow analysis. So it's you're converting all the cash flows into a different form, but the ideas are all going to be the same. Okay. So let's tackle kind of another interesting situation where let's say that we're comparing options where one of them has an infinite useful life. Okay. And so these are things that basically are never expected to be fully replaced. And so again, these could be things like public works projects, so like the roads and the sidewalks. We'll pay. Usually, it takes some money to maintain these over the years, but you're never going to outright sell the road, or the city's never going to sell the tar that's on the road, or sell the concrete in the sidewalk and replace it with something new. So these are things that are planned to be used forever. And so these kinds of situations, they can be a little bit tricky to analyze with at least with the tools that we have, because one thing that we always depend on in our analysis is that it happens over a certain period of time, and so that we have an n to either plug into the formulas or to look up in the table. But for cases where these things are never planned to be replaced, our n is effectively infinity, and so we have to kind of deal with these in a slightly different way. And so, you know, a lot of times, you know, like when the city first built the road, they had to pay a lot of money up front in order to pay for that. Okay. And so if we wanted to compute something like an equivalent uniform annual worth for something with an infinite product life, you know, it might look something like this. Okay. And so this P right here, this would represent our initial cost. I would be our interest rate, and then for N, we would plug in infinity. And so, you know, obviously this is not something that, you know, you can actually compute, because you can't plug infinity in for the formulas, and the compound interest tables, they only go up to 100. So there's no way to actually do this, okay? And so in these situations where, you know, we have an infinite useful life, what we can do instead is we can rely on our concept of capitalized cost. Okay. And so remember, our capitalized costs, you know, if we have something that has an infinite useful life, we can compute the uniform series by just taking the product of the interest rate and our principal, or our present sum. Okay. Yep. And so if you ever come across a situation where the infinite life is, or the useful life is infinite, or if it's something that's permanent, you can compute the equivalent uniform annual worth by just taking the initial cost and multiplying it by the interest rate. Okay. All right. Any questions on this before we do an example involving this guy?
That's IP, correct?
Yeah, IP. Mm-hmm.
Cool. Thank you.
Okay, so let's do an example. Okay, and so let's say that LA County is expecting, or they're considering an expansion to their aqueduct. Okay. And so basically, there's another location where they want to expand the aqueduct, and they can do basically two options. So they can either build a tunnel through some mountains. Okay. Okay. So they're basically just gonna, you know, drill a bomb through mountains, or, you know, whatever they have to do, and then build the pipe that way. Okay. Or they can build a pipe to go around the mountains. Okay. Okay. And so here are the associated costs. We have our initial cost. Okay. And so to go through the mountains, it's going to cost the county 5.5 million. Okay. To go around the mountains, it'll cost the county $5 million. Okay. And so the maintenance on these pipes, you know, for now, we're just going to assume it's zero, just for kind of the sake of simplicity. Okay. All right, so now let's consider how long these pipes are expected to last. And so the pipe through the mountains is expected to be permanent, so it's something with an infinite useful life. Okay. But then if we go around the mountains, you know, this is only going to be expected to last 50 years. So every 50 years, you know, they're going to have to do some major work and kind of replace the pipes. Okay. Okay. And so the other thing that we have to we'll consider is salvage, which we'll assume is zero. Okay. right? So let's assume a 6% interest rate. Okay. And so presented with this information, let's make a recommendation to the county about which option that they should choose. Okay. Okay. And so, this problem is very tailored for a annual cash flow analysis, because we have two different options here. One of them is permanent, and the other one has 50 years. So we have two things with two different years. And what we've learned from before is that if you have options that have different product lives, annual cash flow is a little bit easier because you can do it in kind of one step. And so let's start with that. So let's compute the EUAW for each option. Okay. And so let's do the EUAW for the through the mountains. Okay. And so this is something that has a permanent life. The way that we can compute this is we just multiply I by the initial cost. Okay. And so our interest rate here is 6%, so we would plug in 0.06, and then we would multiply 0.06 by 5.5 million. Okay. And then what we get from this is minus $330,000. Okay. And then we're going to compare that to the EUAW for the option around the mountains. And then what we can do for this, since this only lasts for 50 years, we can actually use our formulas or our table values to actually compute this. Okay, so this is going to be a minus 5 million. Okay, and then let's apply an A over P factor. And then we have an interest rate of 6% and 50 years. Okay. And so if we look up that value from the table, or we use our formulas, and we get minus $317,000. Okay. And so since the EUAW for around the mountains is less negative, or it's higher, then we're going to go with the around the options option. So this is kind of another situation where annual cash flow analysis, works pretty well when you have these product lives, which can be very wildly different, because annual cash flow doesn't really care about that. So as long as you're doing everything in terms of the proper amount of time, especially the ones that are permanent, then you can easily do annual cash flow analysis for situations with different lives. Okay. All right. Any questions on this?
Does that mean that after 50 years, they're not expecting to spend any money?
And so after 50 years, they're going to have to spend another $5 million on that pipe. But in terms of the total economic efficiency, it's actually more efficient to actually keep paying that $5 million every 50 years, which sounds really counterintuitive, right? But if you remember kind of, the fact that money has a time value. And so by going with the around the mountains option, you have $500,000 more today that you can spend on other stuff. And so that the way that you can think of it, that extra $500,000 that you save today, you can invest that, and you can make the $5 million by next time 50 years come around, plus some extra. And so that's basically what this is saying, is that the money you save today is going to be worth it. Even though it seems like you're paying $5 million more every single time, overall it's going to be more efficient because you save more money today. Okay. Okay, so that's a case for when you have an infinite product life and what you can do for that. And so let's look at situations where if you doing an analysis where you have to salvage early, right? And so we did an example like this with present worth, and let's see how to handle these situations with annual cash flow. Okay. And so, these are cases where when you need to salvage early, usually. Okay. And so in these situations where you need to salvage early, and what's going to happen usually is you're going to end up with a lot of irregular cash flow. So kind of very similar to the example we did, kind of the one before this, the last one. Okay. And so in these ones, you just have to be careful using all the proper conversion factors and making sure that you're spreading the uniform series over the entire length of time. Okay. Okay. And so you don't want to run into a situation where you have like something that happens in the middle of your period and you only convert that to a uniform series up to that point. So, oftentimes what this involves is first converting everything to either a present sum or a future sum at the end of your period, and then applying another conversion factor on that to spread it out over the entire time. Okay. Okay. And so let's do an example. Probably we'll start this example and then we'll finish it up next time. Okay. And so let's say that you work for a manufacturing company and you're considering two alternatives for a production machine. Okay. And so first we have machine A. Okay. And so machine A has a useful life of 7 years. Okay. And so the initial cost will be P sub A. Okay. And it has an end of life salvage value of F sub A. Okay. Meanwhile, alternative B, or machine B, has a useful life of 13 years. Okay. And it has its own initial cost of P sub B and salvage value F sub B. Right? Okay. So we have two options, and then they have both different costs. They have different salvage values. Okay. They have different project lives too. Right. And so let's say that we only want to use these machines for 10 years. Okay. Okay. And then our interest rate is 6% or 8%, sorry. Okay. And so what we want to do here is that we want to set up the equations to solve for the EUAW for both machine A and machine B. Okay. And so basically we want to perform this analysis for, with annual cash flow. Okay. Okay. Any questions on just the problem setup? Okay, so I think we'll have time to do option A, and then we'll do option B later, okay, or on Thursday. Okay, and so with these kinds of problems, usually the best thing to do is to draw the cash flow diagram. So let's start with that. Okay, and so since our product life is 10 years, so we'll draw this up to 10. So 1, 2, 3, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And so at year 0, we have our initial cost for PA. Okay. And so we know that this machine only lasts for 7 years. So at year 7, we're going to salvage it. Okay. Okay. And since we want to use this for 10 years, at year 7, we have to buy a new one. And so, we're going to plug in PA over there again. Okay. Right. And then at year 10, what we're going to do is we're going to sell our second machine early. Okay. And so F3A right here, which we don't know. So F3A is our early salvage value. Okay. And we'll assume that, and the reason we're kind of keeping these as variables now is because, this is something that we can plug in later. Okay. And so in order to compute an EUAW, we need to convert all of this to a uniform series. Okay. And so let's go ahead and do that. Okay. And so first thing we'll do is we'll do our initial cost. So our initial cost is minus PA. Okay. And then we're going to multiply this by A over P. And then our interest rate is 8%. Okay. And it's going to be for 10 years. Okay. And then to this, we're going to add our thing that happens in year 7. So in year 7, we have an FA minus PA. Okay. Since this is an irregular cash flow, first thing we have to do is we have to take this back to the present day. So this will first be P over F, 8%, 7 years. Okay. And then from there, we can spread it out by doing an A over P, 8%, 10 years. Okay. And then finally, we have our end of time salvage value, which is F3A, and it's going to be A over F, 8%, 10 years. Okay. And so again, the thing I want you guys to focus on is this guy in the middle. Since this guy was an irregular cash flow, we had to perform two conversions in order to get it to a uniform series spread over all 10 years. Okay. All right. Any final questions on this? Okay. So there's no questions. That's all we got time for today. So thank you everyone for coming today. I know I ran over time a little bit, so I apologize for that. And so when we come back on Thursday, we'll finish up this example and we'll finish up the rest of these lecture notes on how to plan out a loan using what we've known for today. Okay. So thank you everybody. Hope you guys have a great day, and I'll see you guys on Thursday.
Hey, Professor.
Yep.
Had a non-class related question.
Okay.
Nothing to do with econ, but yeah, I believe Amy contacted you a while back about if we could get into contact with the business professor.
Oh, yes.
Yeah. So I'll actually be leading our business team for Formula SAE.
Okay.
And we're looking to recruit some more business students.
Okay.
Do you mind
yes.
if we meet during your office hours tomorrow? You said it was around 4, right?
Yeah. Tomorrow office hours. Mm-hmm.
Okay, sounds good. Well, Amy and I will see you there then.
Okay, sounds good.
Okay, thank you.
Yeah.
Hey, Professor, I have a question.
Sure. What's up?
Go ahead, Gang.
Oh, go ahead.
No, you first.
No, you go ahead.
Are you sure?
Yeah, that's cool.
Okay. Thank you. Regarding the circled part, could you go over that again one more time?
Sure. And so basically what that circle part refers to is this cash flow right here, right? The one that occurs in year 7. And so we want to convert this thing in year 7 into a uniform cash flow over the entire 10 years. So this is not something we can do in one step, because if we tried to do this in one step where we did like A over F, 8%, 7 years, what that'll do is it'll basically create a cash flow for all of these years over here, right? So it'll only occur over the 7 years that up to that point. And we don't want that. So we want to spread this out over the entire time. And so what we need to do, you can do this a couple ways actually. So you can, so the way that I usually like to do it, and this is just my own habit, where I like to bring everything to the present day first. And so that's what this first guy does right here. And so what this guy does is it takes these guys and gives us the equivalent sum in the present day. And then because from the present day, you can basically do whatever you want with it. So from this present day, then we'll convert this to an A over P 8% 10, which is the second one right here. And then that'll give the entire uniform series over those 10 years.
Okay, that makes sense. So you just have to do, okay. For the homework, there's some like similar, I could do it that way, but we just haven't learned it yet. I had to like jump back and forth between equations, and it was like, that's nice that there's a way to do it without jumping back and forth.
Mm-hmm. Yeah. So this is something that we covered. I do kind of wish I spent more time on it, but we did cover it a little bit earlier in the class with like how to do kind of more than one conversions for these guys. And problem 3 in the homework is all about this. So problem 3 in the homework, you have to do at least one of these, for those problems. 3B in particular is really hairy because you have uniform series that occur like over here, and then you got to bring it back over here, and then you got to do multiple conversions, and it gets pretty messy.
Right.
Yeah, but for those ones, definitely write out the cash flow diagram and just kind of take it step by step and say like, first, let me take this. Usually a good first step is to bring it to the present day. And then from there, you can do whatever you want with it.
Cool. All right. Thank you.
Yep. Mm-hmm.
Yeah, so what I was going to ask was on the homework for number 2, part D,
2D.
Are we able to use this annual, the equivalent annual analysis?
Oh, yeah,
on that?
Yeah, definitely. Mm-hmm.
Oh, okay. Cool. So we just use the same conversion factor like that we've been doing on these examples? Yeah,
absolutely. Yeah. So a lot of this stuff, it definitely overlaps with a lot of the stuff before. So anything that you want to use for this on the homeworks, as long as you get the answer, then that's all that works. Yeah.
Okay, cool. Thank you.
Mm-hmm.
Professor, I have a quick question.
Yeah, sure. What's up?
For problem 4C, part option B, I believe. Yeah.
Mm-hmm.
I got stuck on that one. I tried it a lot of times and I just can't get it.
4C.
Option B.
Option B.
Yeah.
Let's touch on. Do you have time after class?
I have class at 2:30.
Oh, okay. Yeah, let me check that one. If you want to send me your work for this one, like you just emailed me the PDF, I can take a look. And then anything that I notice, and then I can send it back to you. That one was a little bit complicated though, because it's again one of those irregular cash flows where you have to do kind of multiple conversions for it.
Okay, I'll try it one more time, and if I don't get it, I'll send you the my work.
Okay. Yeah, sounds good.
Thank you.
Yep.
Thank you, Professor.
Yep. Thank you.